Bismillahirrahmanirrahim. Assalamu alaikum and a very good morning. I bid to most esteemed Prof. Dato Dr. Halim Tamuri, the Rector of Quiz, Dr. Mukmin Basri, Deputy Rector of Academic and Research, most respected top management of Quiz, Dr. Muhammad Shahrul Nizam, the Dean of Faculty of Science and Information Technology, Encik Shukri Ahmad, the Director of ICITS 2020, Deans of Faculties, Directors of Centres, presenters and participants of International Conference on Information Technology and Society 2020. I am delighted to be speaking today. Thank you for this opportunity. Some time ago, I was talking to a group of old friends, and the topic Industry 4.0 arose. They were pretty sure that they had no part of involving with Industry 4.0. I presume many would think that way too, right? Surprisingly, Industry 4.0 concerns us more than we know. Towards the end of my presentation, you will have a clearer understanding of Industry 4.0. What technologies are involved? Who are directly and indirectly involved? What are the issues and challenges that we face? And what are the strategies laid out by the government? And by doing so, we can help contribute by playing our roles to ensure the success of Industry 4.0 in our country. To begin with, the first industrial revolution started with the emergence of steam and water power, enabling mechanization of production processes, while the second industrial revolution was driven by electric power and mass manufacturing techniques. Information technology and automation brought in the third industrial revolution. The fourth industrial revolution is exploding on the back of a range of technologies comprising of physical, digital, and biological spaces. Industry 4.0 transforms how products are designed, fabricated, used and operated, as well as how they are maintained and serviced, which will also transform the operations, processes, supply and management, and energy footprint of factories. So these are technology enablers. The digitalization of production-based industries are driven by these technological drivers. Now let's look at them one by one. Additive manufacturing is advancing with the use of new materials, opening completely new possibilities. For example, 3D printing of organic tissues has created opportunities for growing live organs. It is revolutionizing traditional production, aided by a recent surge in metal additive printing. Artificial intelligence is a concept that is made up of numerous subfields, such as machine learning, which focuses on the development of programs that can teach themselves to learn, understand, reason, plan, and act when exposed to new data in the right quantities. AI technology will supplement the smart factory towards networked factory, in which data from supply chain, design teams, production lines, and quality control are linked to form a highly integrated and intelligent engines. Big data analytics. Increasingly, big data techniques are being applied in manufacturing industry to improve a customer experience and product quality, realize energy efficiency, and conduct predictive maintenance. It is now possible to collect masses of data from several different sources to direct decisions that anticipate product or equipment failure. Next is advanced materials. New materials and nanostructures are being developed, allowing for beneficial material properties, for example, shape retention and thermoelectric efficiency. Together with additive manufacturing technologies, it will allow for massive customization and development of products that were not possible until now. Cybersecurity. The industrial communication is expanding and strongly connected. As such, digital security becomes a critical aspect that must not be overlooked in the industrial environment. It has now become a more complex as it consists of connected devices and environments that cannot be protected by a traditional cybersecurity approach. Current cybersecurity has largely been developed for IT-centric devices and environments. Augmented reality. The initial augmented reality technologies are still in young stages, yet they are advancing at a rapid pace. Some of the first applications can be found in the delivery of information and training. For example, augmented reality can be used to deliver part replacement instructions to maintenance staff in the field. Simulation. Okay, so while many engineers are already familiar with simulations in the field of product design, the advent of augmented reality, artificial intelligence, and big data is expected to take simulation to the next level. It will be possible to simulate manufacturing processes using different production settings to find the optimal way to manufacture a product. Simulations can also be used to test product usage under different operating environments using different types of material. Cloud computing. With cloud computing, many of the Industry 4.0 technologies can be made available even to smaller companies as a utility with minimal upfront capital investment. Companies can leverage cloud-based product design, simulation, artificial intelligence, and big data solutions to improve their production processes and build products better suited for their customers. Internet of Things. Industry 4.0 technologies embody an unprecedented large amount of sensors and connectedness among these sensors. Combined with other technologies such as artificial intelligence and big data, It is now possible to anticipate entirely autonomous systems that revolutionize manufacturing. Autonomous robots, machinery, and robots are transformed towards their next generation. Robots can do more than their own, including learning on the job and teaming up with other robots and humans. This technology allows systems to think, act, and react autonomously, as well as conduct remote decision-making. This can help contribute to a company's competitiveness, productivity, and profitability. The last one is system integration. System integration occurs in vertical and in horizontal systems, eventually achieving end-to-end digital integration across the entire value chain. We now look at the focus sectors of Industry 4.0 in Malaysia. The first sector is electrical and electronic. The electrical and electronic industry is the leading industry in Malaysia. In Malaysia's manufacturing sector, contributing significantly to the country's exports and employment. Second is machinery and equipment. The machinery and equipment industry is one of the key areas for growth and development, focusing on high value-added and high technology M&E. Chemical. The chemical industry is one of the catalytic industries in the country with rapid growth due to the availability of oil and gas as a feedstock. Medical devices. The medical device industry spans an extremely wide range of industries from rubber and latex, plastics, machinery and engineering support, and electronic. Aerospace industry has been designated as a strategic sector with high growth potential in the country's industrialization and technological development programs. Other sectors include automotive, transport, textiles, pharmaceutical, metal, food processing, and services. The key question is, how ready is Malaysia for Industry 4.0? The recent report on the readiness for the Future of Production Report 2018, jointly published by the World Economic Forum and A.T. Kearney, provides a global assessment of 100 countries and positions Malaysia in the leader quadrant. Now, these countries with a strong current production base and who are positioned well for the future. It is also interesting to note that Malaysia and China are the only two non-high income countries in the leader quadrant. This puts Malaysia in a challenging position, as it highlights the economic value at stake if Malaysia is not able to transform itself in an accelerated manner. The gap to global leaders like Japan, Republic of Korea, Germany, Switzerland, and China is still significant. And these countries have aggressive plans and are moving fast in their implementation. Let's now look at Malaysia's issues and challenges on the demand side. Alright, so in terms of awareness, there is a lack of awareness on the impact of and need for Industry 4.0 technologies, both in terms of opportunities and business model disruption, especially among SMEs. Next is in terms of innovation, evolving customer expectations and demand for customization of products and faster delivery. Also, ownership of intellect properties due to interconnectivity and information sharing along the supply chain. Next challenge is digital readiness and connectivity. First, low digital adoption, especially among SMEs, which is about 20%, and limited use of automation by manufacturing firms, where majority of firms use less than 50% of automation. Second, lack of integration and digital approach to data gathering along manufacturing and supply chains. And third, exposure to cyber threats with increased connectivity and new technologies, especially IoT. In terms of skill enhancement, limited understanding of manufacturing firms of required future skills and expertise, and own readiness to embark to Industry 4.0 transformation. Also, significant shortage of required talents, skills and knowledge for Industry 4.0, particularly in the areas of IoT, robotics, and artificial intelligence. Next is in terms of high cost and investment, higher cost of adoption and lower payback period for Industry 4.0 technologies and processes. Also, there is also inadequate understanding of cost versus benefits and ability to conduct Industry 4.0 business case analysis. The last one is in terms of best practices. There is lack of a centralized and easily accessible information platform to understand best practices and relevant use cases. And also, there is a few visible success stories of applying Industry 4.0 technologies and processes by local companies. Alright, so we now look at Malaysia's issues and challenges in terms on the supply side. First is on governance. Multiple but isolated efforts and limited coordination among all stakeholders in moving towards a common vision for Industry 4.0. Also, no national platform and mechanism to coordinate programs and structure collaborative and aligned approaches for Industry 4.0 requirements. Next is in terms of funding and incentive. Existing but underutilized funds for training and development and need for higher education for STEM education. Also, no specific financial support and incentives for Industry 4.0 technology development, ranging from R&D, prototyping, testing, scaling up to upgrading facilities. Next, we look at ecosystem support. First, a limited number of local players providing Industry 4.0 solutions across key technologies and not cost competitive with regard to international players. Second, limited collaboration and industry take-up of Industry 4.0 outputs from universities and research institutions. Third, shortage of experts in the industry, universities and research institutes across most Industry 4.0 technologies. And the fourth, inefficient local capabilities and capacities in providing cybersecurity solutions that protect Industry 4.0 applications. Next is in terms of training providers. Education syllabus and pedagogy for STEM-related subjects are not attractive and do not match with industry needs. Also, limited attractiveness of manufacturing as career destination for top talent. Lastly, existing training programs are not sufficiently geared towards Industry 4.0 and current pool of trainers are unable to keep up with the advancements of technology. In terms of standards and digital integration, limited digitalization and digital integration of key government agencies and processes into manufacturing and supply chain. Also, lack of clear standards for equipment or systems that support local and global interoperability of Industry 4.0 technologies and processes. Last is in terms of infrastructure, gaps in deployment of high-speed broadband infrastructure in key industrial and training locations and not always able to support Industry 4.0 technology needs. We now come to the national strategies under the acronym FIRST, F-I-R-S-T. Under F, for funding and outcome-based incentives, Strategy F1. Provide outcome-based incentives, including tax incentives, to encourage investments in and adoption of Industry 4.0 technologies and processes. Strategy F2. Introduce dynamic and innovative financial products to encourage the adoption of Industry 4.0 technologies and processes. I for enabling ecosystem and efficient digital infrastructure. Strategy I1. Strengthen the digital connectivity in and between industrial, education and training hubs. To remove connectivity bottlenecks in adopting Industry 4.0 technologies. Strategy I2. Enhance the digitalization and integration of government processes and infrastructure along supply and manufacturing value chains. Strategy I3. Involve service providers for Industry 4.0 and link them to manufacturing firms. This is to help implement technologies, processes, and skill development. R is for regulatory framework and industry adoption. Strategy R1. Increase awareness of the need, benefits, and opportunities of Industry 4.0 technologies and business processes among manufacturing firms. Also, Strategy R2. Create a platform and mechanism to help manufacturing and related services firms, especially SMEs, assess and develop their Industry 4.0 capabilities. Strategy R3. Improve data integrity, standards and sharing. Strategy R3. Improve data integrity, standards, sharing and security to facilitate seamless integration of manufacturing value chains and support intra-ministerial coordination for effective Industry 4.0 programs. S is for upskilling existing and producing future talent. Strategy S1. Enhance capabilities of existing workforce through national development programs, specially designed for specific manufacturing sectors and support reskilling and upskilling. Strategy S2. Ensure the availability of future talent by equipping students with the necessary skill sets to work in the Industry 4.0 environments. Last one is T, which is for access to smart technologies and standards. Strategy T1, establish digital or technology labs and collaborative platforms, especially public-private partnerships to create awareness and understanding, foster the adoption of new technologies, and facilitate the transfer of knowledge. Strategy T2, establish and implement standards for interoperability, quality, and safety for smart manufacturing and Industry 4.0 technologies. And last, strategy T3, intensify research, innovation, commercialization, and entrepreneurship programs and activities in a specific Industry 4.0 technologies and processes that support and advance priority sectors. Transforming a Malaysian manufacturing sector is not a short-term process, where many industries have experienced significant challenges for decades. A supportive policy environment is required over the next decade to provide businesses with stability and allow them to execute these long-term strategies. Propelling Malaysia's Industry 4.0 transformation will require a joint effort across many ministries and agencies, industry, research facilities, and academic institutes. Every entity has to elevate its role and fill in the transformation gap. Ready or not, the inevitable Industry 4.0 is here. If you would like to read more on this, you may refer to the National Policy on Industry 4.0. Any questions or comments, please don't hesitate to email me at juzlinda@quiz.edu.my. Thank you for your kind attention and enjoy the rest of the conference. Good day. Assalamualaikum warahmatullahi wabarakatuh.